is domain and range of functions, okay? And I think we may have mentioned this a little bit last week, talking about what the domain and the range of the functions are. Your domain is going to be the x values of your function. And your range is your y values. On a problem like number 1, it's actually just going to give you a graph that has several points on it, just individual points, okay? And I did send these out on Friday, so if you printed them off, especially on a section like this, it may be easier to see exact stuff on your graph, but I'm going to try to recreate as best I can. So domain is x, range is y. Let's look at number 1. I left my glasses at home. Still one of those. Okay, so this is a recreation of the graph that is on number 1. Okay, now it's going to ask me 4 different things. Okay, and in 2 of those 4 things are going to be what are the domain and the range. I'm actually going to do those 2 parts first. Okay, when you have a set of points and it's asking you for the domain, it's literally just asking you what are the x values of those points. So before I answer any of the questions, I'm actually just going to write out the ordered pairs that go with these points, because if I do that, then I'll be able to use that list of ordered pairs to answer all the questions. You'll see how it'll make, even though it's a little work on the front end, it's going to make answering the 4 question parts easier. Okay, so starting with this farthest left point, again, I'm just listing out the points. So let's see, its x value, it's lined up with -4, +6. So that's going to be the ordered pair that made that point, right? Because it's left 4 and up 6. Left 4, up 6. That's what got you to that point, was those 2 movements. What got you to this point? Left 3, up 5. So that point is at -3, 5. This point, left 2, up 4. So -2, 4. This point, left 1, up 3. So -1, 3. This point is at, I didn't go left or right at all, correct? I just went straight up 4. So left and right, 0, up 4. To the right 1, up 5. So now I'm at +1, 5. And to the right 2, up 6. So I'm just listing out the ordered pairs that made those points. Now I'm going to say what the domain and the range is. Your domain, which would be all your X values. If you see any repeats, there's no need to write the number twice. Okay, so on my domain, let's see, I've got -4, -3, -2, -1, 0, 1, and 2. So all of those numbers are in your domain. So -4, -3, -2, -1, 0, 1, 2. So there's your domain. Now your range is just the Y values, and again, list your Y values. There's just no reason to, if you see one listed more than once, to write it twice. Let's see, I've got 6, 5, 4, 3, then I have 4, 5, 6. So 4, 5, and 6, I see twice. I just need to write it once. So if I'm writing my numbers from my range from the smallest to the largest, it doesn't necessarily tell you you have to do that. It'll just be 3, 4, 5, and 6, right? Those are all your Y values that you see. 3, 4, 5, 6, and then again 4, 5, 6. That's why I did. That's why you have fewer numbers in your range than in your domain. You just had repeats in your range. The other thing it's going to ask you on this one is two things. It's going to ask you to find f of -2. So now that you have the ordered pairs written out along with the picture of the graph, you can use whichever one is easiest for you. It's easiest for me to use the points written out. Okay? What this means is the number that's inside the parentheses is always representative of the X. So it wants to know what is f of -2, or in other words, what is the Y when the X is -2? So you can either find the X being -2. Here's my X is so there's where the X is -2. So you just trace it over to the Y, or come in your points that you've written out. Find the one where the X is -2. What's the Y that goes with it? 4. So when X is -2, Y is 4. And then the last part of this one says, find any X value or values for which f of X equals 4. So let me show you what that's talking about. So when you see it written out like this, remember what's interchangeable for the term or for the language f of X. That's the same thing as saying Y. So that's saying, in other words, what are your X value or values when Y equals 4? So you could either go to where Y is 4 on your graph, which is right here. So anything lined up with this Y equals 4 is what you're going to use. So I can either use the picture, and I see there's 2 of them. Or in my opinion, I can now, since I did the legwork at the beginning and wrote out the ordered pairs, I am just looking for any point where the Y coordinate is 4. Let's see. 6, 5, so this one. And that one, right? There's 2 points where the Y coordinate is 4. Just like the picture shows, both of these points are up 4, right? If you're up 4, that means your Y coordinate's 4. So what are the X's that go with them? -2 and 0. are the 2 points where the y coordinate is 4. All right, number 2. So number 2 is going to ask me all the same questions that this problem did, except the graph is not going to be separated points. It's going to be a continuous graph. And again, I'm freehanding this. You'll see why. Okay, so just like the last one, I'm going to do domain and range part first. Okay, when you have a continuous graph, you're kind of trying to find where the graph stops and starts and continues. So on this one, the domain is your x values, right? We don't have separated points this time, so I'm not just going through looking for ordered pairs. I have a continuous graph. So when you have a continuous graph like that, and you're talking about your domain, your x values, you're looking at your x-axis and seeing how far left and right does this graph cover? And is there any gaps in it, or does it stop going left or right at any point? So looking at this graph, what's it doing from here, left and right wise? This arrow means it's going to the right forever. What is this side doing? Going to the left forever. Is there any point of that x-axis, if I went on forever and ever, that would not be covered? There's not. It's going to go this way forever and this way forever, which means there's several different ways that this is called. Sometimes they'll say negative infinity to positive infinity. Sometimes they'll say all real numbers, which is what this one says. The domain is all real numbers. There is no part of this graph where it's not going left and right. And I think once you see the range where there is a stoppage point, you'll see why the domain is forever left and right. Yeah.
On it's not the leading brackets rather than
when those wavy brackets, when we're doing interval notation, we're going to do exactly what you have right there, negative infinity to positive infinity, just like you have right there.
Okay.
Yeah. Yeah. So the other way that you would write this is what she's talking about is this all real numbers. Another way to state that is from this, the sideways 8 is an infinity. So from negative infinity to positive infinity is just another way to say all the real numbers on the number line. Now, your range is talking about how far up and down this goes. Because your range is your y values. I can see from this graph, this right here is the lowest point it's ever going to be, isn't it? It's not ever going to go below that because what's it doing out of each side of it? Going up. So it's going to go up forever from that point, but nothing below that point is included in the range. Remember, range is up and down. So what I need to know is this is going to be the lowest y value of this graph. So what is the y value at that graph? I mean, at that point, its x is 1, 2, 3, 4, 5. What's its y? It's 0, right? 0 is the very lowest y value that's going to be represented in this graph. It does touch this point, which is important because this is going to be a multiple choice. It's going to ask you which one it goes with first. And then the other one is all real numbers. It's not going to be all real numbers this time. So just make sure that you're choosing the right one. What is y? The lowest y is 0. Y is all the numbers greater than or equal to, right? I want to include the 0. So greater than or equal to, which would be this one, right? Greater than or, bless you, greater than or equal to 0 is what your y values are that are represented in this graph. And then it asks me those other kinds of questions. Like this, the first part of this is what is f of 2? Which means what is your y when your x is 2? So here's where x is 2. Go touch your graph from there. So if x is 2 here, anything that lines up on the graph with the x being 2 is what you want to be included. That's why I put that point there. That was looking ahead. So what is, if this is where x is 2, that's the point that's going to the right 2. It's also up 3. So what is the y at that point? 3. So f of 2 is 3. And then it wants to know for what x values is f of x 3. So in other words, where y equals 3, what are your x's? So let's think about this. Where is y 3? It's 3 right here. So anything that is lined up with the y being 3, that's a point on the graph that has gone up 3, which makes its y coordinate 3. I see 2 points that are doing that, right? These 2 points right here are both on this graph, and both their y coordinates are 3 because they're both up 3. So this one's x is what? 2. And then this one's x is 8. So 2 and 8 are the points on the graph where the y is 3. Now, the next problems all the way through the end, they're not going to give us a picture of the graph and ask us to find the domain. They're going to just write out the function in numbers and words and X's. Okay, and ask us what the domain is. So if it gives you a function and asks what the domain is, you're literally looking at the function and saying, is there anything I wouldn't be able to plug in for the X? I don't want to plug in something that's going to mess this up. The one restriction that we're looking for in this section and in this, this section is if you have a fraction with an X in the denominator, there's going to be numbers that you wouldn't be able to plug in for X. The reason why is, let's just say you have this fraction here and you tried to type that in your calculator, it's going to give you an error message, right? Because what can you not divide by? 0. You can't divide by 0. So if you have a function and there's an X in the denominator, you need to make sure that you're not going to choose to plug in a number that would turn that denominator into X, like on number 3. That's called undefined. You can't divide by 0. So number 3 says, find the domain of this function. F of X equals 6 over X plus 14. My function is a fraction. It's called a rational function. There is an X in the denominator of this rational function. So I just need to make sure that X plus 4 does not equal 0. I don't care anything about the top. Top numerator can be anything it wants. But the denominator cannot equal 0, right? That's what we want to put a stop to. So just whatever your denominator is, now most of you can look at here and say, oh no, X better not be negative 14, right? That's what's gonna make that 0. You're not always gonna be able to just look and tell. So the step is to say, whatever your denominator is, just set it up to not equal 0, but then just solve it like a regular equation, which means get rid of plus 14 with minus 14. Bring down your X. Cannot equal 0 minus 14 is negative 14. So X is a real number, which means it can be any number. It just can't be negative 14, right? If I put negative 14 in here, what are you going to have? 6 over negative 14 plus 14, which is 6 over 0, which is what you can't have. Okay, so just if you have a fraction with an X in the denominator, set up its denominator to not equal 0 and then solve it. That's going to give, then X can be anything else. It just can't be that number. All right, number 4. P of X equals 2X minus 5. So on this one, think about what you're going to be doing to any number that you plug in for X. You're going to do what to multiply times 2 and then subtract 5 from it. Is there a number on the number line that you cannot multiply times 2? You multiply whatever you want times 2, right? Doesn't matter if it's negative, 0, a decimal, a fraction, anything. You can multiply any number you want in the world times 2. You can also take 5 away from any number, right? There's not a number that you can't take 5 away from. Okay, so this one is just X is a real number. No restrictions. Number 5, same kind of thing, right? Think about what you're going to plug in here. What are you going to do to it? Square it, which means multiply whatever you're plugging in times itself. And you're going to add 2 to it. There's no restrictions on any numbers to square them or add 2 to them, right? You can multiply, if you plug in a number here, even if it's a crazy decimal or a negative fraction, you can square it, you can times it times itself, and you can add 2 to it. So there's no restrictions on that one either. So again, x is a real number. So for all purposes in this section, all we're looking for that's going to give us a restriction is x's and denominators. Right, number 6. G of x equals 9 over 6 minus 5x. So I do see a fraction. That's what sets me off first. And there is an x in its denominator. If there's not an x in its denominator, then you don't care. But if there's an x in the denominator, that's where you're going to be replacing with numbers, right? The x is where you put the numbers. So this time there is going to be a restriction, right? So my denominator can't equal 0. Solve it for x. The number hooked onto the x never goes away until the last step, always. So I'm going to get rid of that positive 6 with a negative 6. I'm going to subtract 6 from both sides. So now I have negative 5x cannot equal 0 minus 6 is negative 6. Now divide by exactly what's hooked on. You want to cancel out that negative 5, so you're going to divide by negative 5. That negative 5 cancels that one. There's your x all by itself. So x cannot equal that negative over negative. This times it to positive 6/5. So x is a real number, and x cannot equal 6/5. Okay. Number 7. Give x equals the absolute value of x minus 4. So again, here's my x. It's inside an absolute value bar, which means numbers that I'm going to plug in, what am I going to do? I'm going to take the absolute value of that number and then subtract 4 from it. There's nothing you can't do that to, right? Because what does absolute value mean again? It means how many spaces away from 0 are you? Well, no matter what your number is, you're that many spaces away from 0. Right? So there is nothing that you wouldn't be able to plug in. And last one. And then we're going to do start 2.4. Plugging in, is there anything you can't multiply times itself 3 times? Or subtract 9 times? No. No, I can do both of those operations through any number. Again, the whole section is looking for domain and range, whether you're given the picture or whether you're just given the function written out. If your function is written out, you're looking for a rational function that has an x in the denominator to find any restrictions. All right, now in 2.4, they're going to give us 2 functions and then just ask us to do different things to those functions. It may be add them together, it may be multiply them together, it may be plug in numbers and then add them together. But they're all going to start off by giving us 2 functions and then give us instructions on what they want us to do with those functions. So again, this is the start of 2.4. The 2 functions that it gives me in 2.4 is f of x equals x minus 1, g of x equals x squared minus 5, oh, hang on, that's not right. I was looking at 9.1. Hang on. G of x is x squared minus 4. My bad. G of x is x minus 3. All right, that should match your thing, right? And on this one, it wants us to add f plus g of x. That's how that's worded. F plus g of x. So essentially it wants me to add my f function to my g function. So my f function is x squared minus 4. My g function, which is what I'm going to add the f one to, so just add it to x minus 3. The word add is just a very simplified way to say combine your like terms. Now remember what like terms are. Your like terms are any terms that have the same letter or variable, and that variable has to have the same exponent also. So which terms can you put together to clean this up? That's right. I can put those together to clean that up. So I can't put anything with the x squared. Can't put anything else with that x. But I can put -4 minus 3 together to get -7. So just clean it up by combining like terms. Yeah. No. Okay. So this right here, like where? So I'm glad you said that, because usually when you see 2 parentheses bumping up against each other like that, that means to multiply them. So I'm really glad you said that. So this when you're talking about the algebra of functions, this right here, it actually means that you're going to find both of these, f of x and g of x, and then add them together. So this, I'm trying to, that's confusing, isn't it? Because it's even going to be more confusing when we do the next one, because it is going to be multiplication. This right here, if you have a parenthesis, first of all, if you're given 2 functions, and then you have a parenthesis with either one of these letters in it, like this, that means you are doing something with these functions and not actually doing any multiplying right there, unless this is a multiplication symbol right there.
The way I had it explained to me was
Good.
it's the same. F plus g of x is the same thing as f of x plus g of x.
Yes.
It's just,
Yes. that's a good way to say it. Another way to write this is this is the same thing as saying f of x plus g of x. So that would tell you even more clearly to add the f of x function to the g of x function. It is confusing. These two things mean the same thing. And sometimes you'll see it actually written out like that, which I think is clearer when you see it written out like that. Okay, let's look at number 2. So it's going to give us another f of x and g of x. This time f of x is x squared minus 3. And g of x is x minus 2. And they said now define f times g of x. So just like you were saying, another way to say that is to find f of x times g of x. That's just another way to say that. So it wants me to do my f of x function. What is f of x? X squared minus 3 times my g of x function. So here's where I think you're getting this from. Because if I'm multiplying x squared minus 3, and I'm going to multiply it times x minus 2, right? So I am going to write that out like this. That's meaning to multiply those two functions together. Now, when you see these are two what are called binomials, each thing in the parentheses has two terms. So I have to distribute this x squared goes to both of those. Once I finish doing the x squared, I'm going to start all over and do the negative 3. Distribute it to both of those. You may have heard that called FOIL. If you were fairly recently out of high school. FOIL, first, outer, inner, last. That's what this is doing. Okay, so my first x squared times x gives me x to the third power. Right? Because what do you do if I'm multiplying x squared times x to the first? You're going to add their exponents. So x squared went to x. Now x squared needs to go to negative 2. So x squared times negative 2 is just negative 2x squared. If you multiply a letter times a number, it just hooks them together. So x squared times negative 2 just going to be negative 2x squared. This is my inner part of FOIL. Just distributing the negative 3. Negative 3 times x is just negative 3x. My last, negative 3 times negative 2. Negative times a negative turns out to positive 6. Now, after I do that FOIL, that multiplying, I do look to clean this up, but are any of those terms like terms? No, none of them have the same exponent. So I can't even clean it up. That's just as far as you can go. Okay, we're just going to go through 5 today. We're just going to go through that front page. All right, number 3. My f of x is x squared plus 1. My g of x is x plus 3. I want to find g times g of x, or g of x times d of x. So it gives us an f of x, but it doesn't even ask us to do anything with it in this problem, right? So this is meaningless for this problem. So g of x is x plus 3. So x plus 3 times another x plus 3. Then I'm going to FOIL that one also, or distribute. First, x times x gives you x squared. Your outer x times positive 3. This is positive 3x. My inner positive 3 times x is positive 3x again. And then my last positive 3 times positive 3 is positive 9. Can this one clean up? Yeah. Those x's can be put together, right? There's no reason to write 3x plus 3x separately when you really just have how many x's? 6 of them, right? So all I need to do to clean this up is put those x's together. So x squared, I really have 6 x's in the middle, plus 9. Now, this is not 6x squared, right? How did I get this x squared? X times x. That's how you get x squared. You don't get x squared by adding 2 x's together. You just have more of those x's. Number 4. F of x is negative 13x plus 12. G of x is x squared plus 13. It wants me to find f of negative 3 plus g of negative 3. So this time I'm not adding them together as they are. I'm finding what f of negative 3 is, what g of negative 3 is, and then when I find those two things, I'm going to add them together at the end. So what does f of negative 3 mean to do? It means to go to my f function and replace its x with negative 3. So if I do that, I have negative 13 times negative 3 plus 12. Negative 13 times negative 3 is positive 39 plus 12, which gives me 51. I need to do the same thing. I gotta find g of negative 3. Which means go to your g function and replace its x with negative 3. So I have negative 3 squared plus 13. Remember, if you square a negative in your calculator, you need to make sure you put parentheses around it. If not, it's going to tell you the wrong thing. Negative 3 squared is positive 9 plus 13, which gives me 22. So I've got 51 and 22. What does it want me to do to those two numbers? Add them together, which gives me 73. All right, I'm going to put the last one on the board, and I'll call roll while y'all are just looking through it. It's very similar to number 4. So on Wednesday, we'll be able to start with number 6. F of x equals negative 8x plus 20. G of x is x squared plus 16. And it wants me to find f of 4, this time minus g of 4. You're going to do the same thing you did on the last one. It's just instead of adding the two answers together at the end, you're going to subtract them.